In this video, I will discuss NIST guidelines on firewalls and firewall policies. And this video is based upon NIST Special Publication 800-41. So let's start. Now this document is divided into 4 parts, that is Firewall Technologies, Firewall Architecture, Firewall Policies, and how to plan and implement firewalls in your organization. So once we talk about firewalls technologies, so there are packet filtering firewalls, stateful inspection firewalls, application firewalls, proxy firewalls, and unified threat management. So the packet filtering firewalls are the basic firewalls. So nowadays routers perform this packet filtering features. So this packet filtering firewall inspect the traffic based upon the IP addresses and also the TCP or the UDP port. So IP operates at layer 3 and TCP and UDP ports operates at layer 4 of OSI model. Now the stateful firewalls or the stateful inspection firewalls are more advanced than packet filtering firewalls. So stateful firewalls also maintain a state of all the sessions which are initiated. For example, if a specific rule on the firewall has allowed a certain kind of traffic to be initiated from your internal network to go out, then once the reply come back against that traffic, then there would be a session table maintained on the firewall which would allow that reply to go or to pass through the firewall, since this traffic was initially or the initiated from your internal network. Then this application firewall inspect the traffic based upon the content of that traffic or layer 7 of OSI model, that is the application layer. So if for example if there are two applications, the instant messaging application and also a web application, and you have allowed only the web application on your application firewall, so even if both the applications are using the port 80, this application firewall would not allow the instant messaging traffic to pass through the firewall. The next firewall is the proxy firewall, which act as an intermediate device to traverse the traffic on behalf of internal host. So outside world would be communicating with your proxy firewall, and then this proxy firewall would forward that traffic to your internal host. Then is the unified threat management. So unified threat management are the firewalls which can combine multiple features. For example, all the features of the firewall which I have discussed earlier can be combined in this unified threat management. And there are certain other features, for example, the VPN or virtual private network, which can be configured or provided by the firewall. So the virtual private network provide point-to-point connection between two firewalls if this VPN is established. So our traffic would go inside the VPN from one firewall and it would come out from the other side or on the other firewall. And this traffic would think that this is just a point-to-point devices which are communicating, whereas in the physical deployment there are certain routing devices which would be deployed between these two firewalls. So this VPN provide a tunneling feature for the traffic, so the routing devices would not be able to see that traffic. Then this network access control provides a kind of access control for your internal network. For example, if there are multiple clients which wants to connect to your internal network and this NAC feature is available on your firewall, then you can control what all kind of clients can connect to your internal network. So this network access control is basically targets your internal security for your internal networks. Then now due to virtualization, the server form has been virtualized, and also the network of those virtualized server. For example, the VMware provide a product known as NSX, which can virtualize the networks, and which can provide the virtualized switches, virtualized router, and also virtualized firewalls. Then is the host based firewall. So these firewalls are the firewalls which are deployed on individual system or individual servers or maybe individual laptops. Then there are certain limitations with firewall technologies. For example, uh, the firewall cannot block the traffic which is unmeaningful to it or which is encrypted. So there are certain protocols which can encrypt the traffic. For example, the Secure Shell Protocol, IPsec, TLS, SMIME, OpenPGP. So SMIME and OpenPGP are the email encryption protocols. And then is the tunneled IPv6. So if there is an IPv6 traffic which cannot, uh, uh, which is tunneled inside IPv4 traffic, and your firewall cannot understand the IPv6 traffic, then it will allow that traffic to go. So solution is that you can block all the traffic which is not authorized to be encrypted or maybe to be tunneled. So there are certain recommendations at the end of this section of this document, that NAT should be considered a routing feature, not a firewall feature. Moreover, you have to permit only the outbound traffic that uses the IP addresses which are used internally in your organization. So any traffic which is initiated from your internal network but does not have the IP addresses or the source IP addresses of the internal network should be blocked. Then you have to perform the compliance checking in firewall for the traffic which has been blocked. So firewall can also act as a application proxy. So any application server which is residing inside your network and is communicating with the outward or to the outside network, then your firewall may act as an intermediate proxy, and it can communicate to the outside world on the behalf of that application server. So in this case, your application server would be more secure instead of directly interacting with the outside world. So centralization, moreover, all the firewalls which are installed on individual servers or individual clients can be centralized for uniformity or for consistency of organization policy. The next portion of this document is the firewall architecture. So there are different firewall architecture or deployment options. For example, there is a simple deployment of firewall in which all the internal hosts are connected uh, to the firewall, and then this firewall is connected to the outside world. Or there may be a DMZ or an additional security zone which can be deployed to communicate with the outside world through the firewall. So outside world would only communicate with this server inside this DMZ zone, for example your web server, and then your web server would communicate with the internal database server. So this database server would not be visible to the outside world directly. Then there is network address translation, which I have discussed earlier. So network address translation basically protect or your internal IP address scheme. So your internal server's IP addresses are not visible to the outside world because these has been netted and translated into the public IP addresses by the firewall. So the outside world would only see your public IP addresses and would not know the internal IP addresses. Then you can deploy the firewalls in layers, that is, one firewall can be put behind another firewall. So these are different deployment options. So for deployment of any firewall in your organization, you have to assess your current architecture, and you may have to change your current architecture for deployment of any firewall. Then you have to specifically allow what internal services can run and what services can be visible to the outside world through DMZ or demilitarized zone. For example, your database services should be only visible to your internal network, whereas your web services should be available at DMZ for the outside network or for the outside users. Moreover, once you are going to deploy two firewalls in series or one firewall behind another firewall, then you have to balance the security requirement with the availability of these services, since this deployment may cause certain performance issues. The next portion of this document is the firewall policies. So before devising any policy for your firewall, you have to perform a risk analysis of your organization, and then there should be an implicit deny policy on your firewall. It means that if our traffic is not permitted, then it should be denied by default. Then you have to see the source, then you have to configure rules for filtering the traffic based upon the source IP address or source port or destination IP address or destination port, and also the content of the traffic, that is the application layer data. It means that you have to configure rules for blocking the traffic based upon network layer, that is IP addresses, then ports, that is the transport layer, and also the application layer data. Moreover, you have to block an invalid or private IP address at the firewall. And you also have to consider the possibility of IPv6 traffic and how to handle this IPv6 traffic at your firewall. And then you have to decide what all application can operate inside your network for internal network and also for outside user. So what all application traffic would allow to the outside world. Now the last portion of this document discusses the planning and implementation of firewall in your organization. So this step has this process has four steps, that is planning, configuring of the firewall, then testing of the firewall, then deployment of this firewall, and O&M of the firewall. So in planning, you have to consider your security requirement, and you also have to consider the security feature of the firewall, and the how you will manage this firewall, and the performance of this firewall, and integration with your existing architecture, and how the admin would handle this firewall, what would be their roles and responsibilities, and either this firewall is scalable for your future need. And you also have to consider the physical environment in which this firewall would get deployed. Then you, once this phase is over, then you have to configure the firewall which you have selected, and you have to install the hardware or the software of the firewall, and you have to configure certain rules for packet filtering or for content filtering, and you have to enable logging features on the firewall and also other alerts. Then after configuring, you will not deploy the firewall in your operations, rather you will first test it. So you will test this firewall for connectivity issues or for any rules which you have configured. You have to test these rules as well, that these rules should be in compliance with the organization policy. And then are there any compatibility issues with the application which are running in your organization. And then you have to check either this firewall is easy to manage, and its logging is working fine, and also its performance. So after successful testing, you will deploy this firewall. So you will give notification to the user in case there is any trouble in the services. So they would know that this trouble has come due to the deployment of a new firewall. So they will inform you. And you also have to integrate this firewall with the existing architecture. So after deployment and now this firewall is operational, then you have to manage the patches, any change management in the policies on the firewalls, and also other upgrades to the firewalls. And you may have to perform the audits to check whether this firewall is in compliance with the organization policies. And you may also perform, or you have to perform, this pen testing to check that this firewall can sustain certain attacks. and are there any vulnerabilities on the firewalls. So this was all from my side. Please stay connected. Thank you.